Okay, people listening at home, hi, we're just about to pray. We're going to do a very brief, very celebratory prayer of the Latin Glory Be. We're going to do that this week just because it's nice and cheerful, because holy mackerel, it's good to have you guys back. In nomine Patris et Filii et Spiritus Sancti. Amen. Gloria Patri et Filio et Spiritui Sancto. Sic ut erat in principio et nunc et semper et in saecula saeculorum. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. I am planning to post your exams back to you some difference between today and tomorrow. So you should be able to look those over on your own. If you have any questions, email me. Otherwise, we are launching ahead to chapter 3. Oh my goodness. I could only put in your
We literally haven't been here since October. Okay, so I calculated with that. Since October 21st, October 23rd.
None. That's what I said. You and I, we could have She was there. She was
Okay, gentlemen in the back. Welcome back. Notebooks out. Chapter 3. There's semi-good news here. Chapter 3 is on inequalities. And the semi-good news on this, there are, if memory serves, 5 topics. This will be at the bottom of your homework guide sheets. This will be back into the textbook. Bless you. Actually, there are only 4. A, B, C, D, 3E is a review, extra credit assignment. Notes out. Thank you. Chapter 3. We're talking about inequalities. Gentlemen, save the combos for later. The toughest topics in this chapter we've actually already covered. 3B and 3C are big polynomial less than or equal to 0. Find the intervals where it's true. You just got tested on that. So remember that was a plus minus notation. Find all the ones that are positive or negative and use those. That's it. This chapter kind of sort of assumes that you don't know how to do that, but you do. So there's going to be a little bit of pleasant surprise review in there. So it should be a little less brain busting as far as learning that. Now, I don't know if this is going to be potentially bad news or not. It's not horrible. Do y'all remember corn and wheat problems?
Oh.
Yeah. They're coming back.
It's winter.
Yeah, I know. They're technically called linear programming problems. Linear programming. They don't have to be crops, but that's the one I think of off the top of my head. Does everybody remember how to graph less than's greater than? If I did this, example, y is greater than or equal to 2/3 x plus 1.
Oh, that's shading.
That's with shading, correct. And you have to figure out whether the border is solid line or dotted line. Let's see who remembers. What form is this, first of all? What form of a line is this? There's 4 forms of a line. Good. Slope intercept form. Where do you start? Anybody? Good.
At 1?
At 1.
Y-intercept?
Yeah, the y-intercept of 1. So up, down, left, or right? Up. Would you call that a solid dot or an open dot?
Me?
Whichever. Yes, good.
Solid?
Why would you say solid?
Because it's equal.
Yes. When you have an equals, that means you're going to use solid dots and a solid border. In this case, a solid line. Clear? So, Michael, take over. Where would I go from there? That's a 1.
Go up 2
Okay.
and over 3.
Okay.
Right?
And do what?
And do what?
And do what there?
Oh, put a point.
What kind of a point? Open or closed?
Oh, no,
Closed, solid. What do I use to connect those two?
A line.
Solid or dotted?
So,
Solid. Same reason. A solid line is made out of solid dots. Good, you're most of the way done. A lot of people get so proud of themselves, they say, oh boy, I just graphed this on to the next problem. They say, whoa, you just lost 5 out of 10. What's missing? Yeah, shading. When you have less than or greater than, that means you're going to have to shade one side or the other. Then we happen to remember which way, how you find out which way you shade. There's a way to tell. How do you tell which way to shade? It's either going to be up left or down right on either one side or the other. Yeah, okay.
Don't you plug in a point on one side? Like,
Yeah.
you can plug in 0 in this case.
Test any point. I will make one little qualifier. Make sure the point is not on the line, not on the border. If you test a point that's on the border, it won't tell you anything. Because if you test it, if you're right on the fence, then it comes up true or false. Do I shade up or down? I don't know. But yeah, if you can pull off testing 0, 0, that's a really easy one to test usually. Can somebody plug that in for me? No, go for it.
So like 0, and then it's greater than equal to
Oh.
2/3 times 0, which is 0,
Okay.
plus 1,
So this really means 0 is greater than or equal to what?
1.
1. Is that true or false?
That's false.
That's false. This is arguably my favorite math metaphor. I'm shooting cows aside. Because this is actually the moral life encapsulated in one algebra problem. You tested this point, you tested something and it came up false. What should you do? Should you go toward it or away from it? Away from it. Correct. That's a good life lesson, by the way. If something is false, you run away from it. If something is true, you run toward it. If everybody obeyed this math principle, there would be no sin in the world. But nobody listens to us, do they? End of gripe. You're done. There's a graph. Basically, in real life, I do these light lines just as saving, but in real life, I would take like an entire bucket of blue paint and go, this whole side would be solid blue. Like every single dot up here is solid filled in. All of these points up here are true, and all of these points down here are false. Does that make sense? I just tested one to find out which way to shade, but now I know that all of these points are good, all these points are bad. Everybody right? Yeah, okay? All right. Now, let me just throw you a curveball. I think this is even I forgot. This is an extra credit, probably not. Try this. Graph this one. What shape is it going to be? P. Parabola. What makes you say that? Squared. Yeah. Whenever you have y equals or something like that, something squared, you're talking about a parabola. What form of a parabola is this? There are two forms of a parabola we've covered, basically. Well, three, but standard form and vertex form. Which is it? Yeah.
Vertex.
The vertex form. Vertex form looks like this. Y equals a parentheses x minus h parentheses squared plus k. Which means you should be able to plug the vertex out of this thing if you look carefully. Where is it? Oh, I try this one. Where's the vertex on this thing? You can match it out.
Is it gonna be 2 and
Correct. Why not -2? I like the 2.
what is the minus?
Right. The minus sign is built in, so don't steal it. did everybody see that? The minus sign is part of the formula, so you don't steal that. You pick whatever number is after the minus sign, the h, and then you pick whatever sign is after the plus sign, which is the k. Good. Let's see what we can do to graph this thing. Sophie, take over. Where's the starting point?
Is it,
2,1. Open or closed?
open,
Open. Why do you say that?
because there's no equal sign.
Correct. There's no equal sign, so it's going to be an open dot. Is it going to be a solid or dotted border? Dotted border, correct. The reason I'm not saying dotted line, do we know why?
Because it's a parabola.
Yeah, it's not a line at all, it's a parabola. So when we draw our parabola, it can't be a solid parabola, it's gotta be dot, 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 dot. Can anybody tell me the pattern for a normal parabola? Julia? Over one? Just a plain old parabola. Yeah, there's one.
Over one,
Up one, over two,
up
four, over three, etc. Try it here. Over one, up one, open dot, open dot. And then over two, up what?
4.
4. I'm sorry, I'm running over all my stuff. And then solid or dotted? Dotted. And I'm totally trashing my graph, but that's okay. There's one thing missing. Anybody, what's still needing to be filled in?
Shading.
Shading. Now, there's only two places to shade with a parabola. Inside the parabola, or all the way on the outside of the parabola. I just want to know which one. How do you tell? John?
You plug in a point,
Plug in a point. What would be a good point if we can do it?
0, 0.
0, 0. Note, 0, that's the good thing about having a graph. 0, 0 will tell you whether it's inside or outside. This is an outside point. Let's see what happens. Plug in 0, 0 for me.
So 0 minus 2 squared.
What you got?
Oh, sorry. 0
0
is less than
less than
0 minus 2 squared
Okay.
plus 1.
plus 1.
So that's negative 2 squared, which is 4.
4.
Plus
Plus
1 is
1.
5. And
So it says 0 is less than 5. True or false?
True.
That's true. So what's your verdict?
you shade outside the
You
parabola.
shade outside. The entire outside gets shaded. The inside gets left blank. And that is your answer. Is that clear? So from this point, I'll assume that you know how to graph. If you remember how to graph parabolas from last semester, which hopefully that's true, and if you remember how to graph lines from last semester, which I hope is true, then you should be able to graph these. The only difference is whether it's a solid or dotted border and which way you shade. Okay. Now I'm going to review something from, I believe it was second year algebra. It's a type of graph we haven't done very often. Absolute value. Now, does anybody happen to remember what shape, basic shape that gives you? If you don't worry about it, I'll talk you through it, but yeah. It's a V graph, correct. This is a V graph. It has its own pattern. It's not the same as a parabola pattern. I'm curious if anybody remembers. So from the vertex, gentlemen, what's the pattern for a V graph? Anybody happen to know? Or take a stab again. Yeah. Yes. Over 2 up, 2, over 3 up, 3, blah, 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 over n up, n. Over 5 up 5, over 10 up 10. Start here, over 1, both ways, up 1. Over 2, up 2. That's where it gets different from a parabola. it'll be a perfect V. It'll be a perfect 90-degree angle. That's the graph of an absolute value. So the pattern for an absolute value is over 1 up 1, over 2 up 2, over 3 up 3. It's a lot more boring than the parabola, which is over 1 up 1, over 2 up 4, over 3 up 9. So we sound okay with that so far? Let's see how exotic y'all can get. I'm going to do another equals. Y equals -2, absolute value of x minus 1, absolute value, plus 3. You might be thinking, holy mackerel. This is more than I bargained for. But this is very, very similar to vertex form. And it has the same formula for the vertex, h comma k. The only difference is it's not squared, it's absolute value. So it's not going to be a parabola curving, it's going to be a V shape. So you tell me, where's the vertex? Oh, math people. Michael, where's the vertex on this thing? What comma what? I'll give you a hint, the minus sign is built in, so don't steal it. Okay. The negative belongs in.
So 1 comma x.
1 comma something. You're supposed to pluck out h and k.
3.
Yes, 1 comma 3. Solid or open dot? Michael, solid or open dot?
Solid.
Solid. Anything with equals is solid. This doesn't even have any shading, but anything with an equals is solid. So I'm going to go 1 to the right, 3 up, solid dot. No, I take over. What's the normal pattern for a V?
Over 1, up 1, over n, and over n.
Exactly. What's this going to do?
Almost going to multiply the y by -2.
Yeah, remember this is called the height multiplier. So normally it's over 1 up 1, over 2 up 2, over 3 up 3. Now it's over 1 up.
Down -2.
Right,
Down 2.
I'll tell you that in a second. If you multiply by 2, it's over 1 up 2, over 2 up 4, over 3 up 6, over 10 up 20. Everybody okay with that? So it's twice as tall, height multiplier. And then what does the negative do?
Inverse it and put it
Yeah, it flips it upside down. Let's try it. Over 1, and then what would you say?
down 2.
Down 2. Solid dot, solid dot. Do another one. Start over. Over 2.
Over 2, down 4.
Down 4. I think that'll get us down here. And that should be enough. Good. Done it straight. You're done. Does that seem kind of okay? If this looks new to you, just write this V-graph pattern down. Over 1 up 1, over 2 up 2, over 3 up 3. Otherwise, it's the same sort of modifications we did with parabolas. Moves, resizes, and flips. Moves are when you add or subtract. And if you have vertex form, you don't have to worry about that. But if it's a number multiplied in front, that's an output multiplier. That's why we call it the height multiplier. Its height is output. So the only thing you really have to worry about as far as the height goes, this is over 1, down 2, over 2, down 4. You're multiplying all the heights by -2. If this were -3 in front, it'd be over 1, down 3, over 2, down 6. If this were -10, it'd be over 1, down 10, over 2, down 20. Does that make sense? Kind of following? Let's see if you can follow this one. I'm going to put all the pieces together, and you tell me what this looks like.
Are we not shading the big graph right now?
Excellent question. We are. try that. So, for people watching at home, hopefully you can see this. Y is greater than -3 absolute value of x plus 1 with a plus 7 afterward. So, first of all, can anybody tell me what shape? There are 3 types of shapes we've covered today. Lines, parabolas, and V's. Which one is it? So, what kind of a shape is this going to give you? A V graph. What told you that? Absolute values, correct. Can you tell me, go ahead and take this one too, the vertex. Be a little careful.
Would it be 1 and 7?
Very close. I like the 7. There's something wrong with the form.
Negative 1?
Because what should this have been?
Minus a negative?
Right. Minus a negative. -1, 7. Good. Same thing with vertex form of a parabola. If they put a plus in here, you have to fix it to minus a negative. So the vertex is -1, 7. Let's graph that. Last question for you, Sophie. Open or closed dot? Open. Why do you say that?
Because there's no equal sign.
Correct. No equal sign, so it's going to be open. 1, 2, 3, 4, 5, 6, 7. Open dot. Okay, courageous math people, such as Pete. What's the pattern for a V normally?
Over 1 up 1.
Over 2, up 2. What's this going to do?
So it would be over 1 down 3.
Correct. Over 1, down 3, and do it both ways. What kind of dots there? Another pair of open dots. Start over again. Over 2,
Over 2 down 6.
6. Open, open. And that should be enough for your graph. Solid or dotted border?
Would they be dotted?
Dotted. Open lines come from open dots. An open line has also got a dotted line. Are we done? Do we pat ourselves on the back and move on? And lose 5 points? Answer's no. Julie Miller, take over. What's missing?
So now, shape.
Shape. How do you tell which way?
Plugging it in.
Plug in a point. What would be your favorite point to test?
Can we set a 0, 0?
Sure. As long as it's not right on the border, you're good. Like I would not test, whatever that is, 0.4, because it's right on the border. Okay? So try 0, 0 and tell me what you get.
So 0 is greater than
Uh-huh.
-3, absolute value 0.
You can do the plus if you want.
Plus 1.
Plus 1.
Absolute value +7.
Okay, calculate. What's 0 plus 1? Last I checked. What's the absolute value of 1?
1.
Yeah, just take the absolute value of that and nothing else. So, whoops, I forgot the other part. Plus 7. Keep going.
-3.
Plus 7 is
4.
4. 0 is greater than 4. Your verdict?
It's false.
That's false. What does that mean?
It should be outside.
Correct. We don't shade inside. We shade all the way outside. Questions? Feeling okay? Let me see. Believe it or not, I just gave you a harder problem than the homework's going to give you. Let me show you the homework type of problem. Do you all remember graphing in an MLA? Open dot, closed dot, shade left, shade right?
Oh, yeah.
Oh, yeah.
That's actually the only thing they're going to have you do. I'll do a couple of them with you. Problems like it. Let me show you. Which one are they going to give you? Oh. Wait a minute. What? That's gonna. What? No. Yeah, those cut and paste. Can everybody please take out your homework guide sheet? That's a little bit of bad news, but it's not as bad as you think. This is problems 1, 2, and 3. That is not correct. I'm not sure what happened there, but that would be ridiculous.
Is it too much or too little?
It's too little, unfortunately. I want, let me see,
What page is it on?
page 98. The reading starts on 95.
You already do that?
Not this version I'm giving you.
Not very.
So on page 98 and 99, it spills over to 99. I would like you to do 1 through 7 odd, and I'll do one of those for you. And then I would like you to do 11 through 21 odd. It's actually not as much as it sounds. We're skipping number 9, because number 9 is annoying.
Wait, can you say it again?
Yeah, 1 through, I'll write it on the board too. 1 through 7 odd, so 1, 3, 5, 7. And then 11 through 21 odd. 11, 13, 15, 17, 19, 21.
So like 10 drawings.
Yeah, thereabouts. And let me, I'll actually do one with you, so
We're skipping 9.
we're skipping number 9, correct, just because that's aggravating. I'm gonna try number
11 through 21.
17. X plus 7 upside value greater than or equal to 3. I think that's it. Yes. Number 17. I would like you to solve and graph on a number line. This will call to mind one last technique you might or might not remember, called splitting. To get rid of an absolute value, you have to split it. Quick reference. If you have the absolute value of some sort of stuff equals an answer, how do you solve? You draw what's called a splitting bar. It looks like an upside down goalpost with arrows. 1 plus, 1 minus. You're going to do stuff equals the positive answer. And then you stuff equals the negative answer. And then you solve both of these. You'll have 2 solutions by the time you're done usually. And before we do, let me refresh one last thing. A couple people were looking at me as if I was speaking Greek. There are 4 operations which flip inequality signs if you do them to both sides. There's something you do into problems like this, that if you do it to both sides, this inequality will flip backwards. Less than turns to greater than turns to less than. Does anybody remember any of the 4?
Dividing by negative,
Yes, dividing or,
multiplying.
yeah, multiplying or dividing by a negative. By a negative number. If you multiply both sides by -5 or divide both sides by -3, this flips over. It reverses. It's kind of like looking in the mirror, making everything negative reverse. Let me think of another one. There are 4. I give you a hint. What is that? And give me the right technical term. Holly, what is that? Square root. Guess which one of these causes the problem? Because you get 2 answers from a square root, one positive, one negative. Only one of them is difficult. Guess which one? the negative. Negatives cause these things to flip. So I put in parentheses, the negative answer only. So when you take a square root in the middle of a problem, the negative side answer will flip. This would turn to less than or equal to on the negative side. Third thing, yeah, we're reading big. Oh, without her. Why did I? Oh, never mind. I don't want to know. Third, splitting. If you notice, splitting gives you two answers. One positive, one negative. Guess which one causes the problem? Negative. So the negative answer only. Just as a foreshadowing, this is going to be a test question on chapter 3. I will say what 4 operations flip the inequality signs, and you will list these. And I will require you to put parentheses negative answer only for these 2. There's a 4th, and it's one we're not going to do yet. This is the year where we're going to do this. Reciprocals. If you take the reciprocal of both sides, that'll flip the sign as well. Just to give you an idea, 1/3 is less than 1/2. Does everybody agree? A third is smaller than a half. Take the reciprocal of both sides. 3 compared to, how does that compare? 3 compared to 2. What is the actual true one?
Oh, greater than.
Yeah, sign flips.
Got it, okay.
Makes sense? Yeah. Oh, okay. So go over here and talk me through number 17 on math table. Who's feeling courageous? I want to get x by itself. What do you have to do first? What do you have to get rid of first? I'd like to get rid of the 7. There's something further away though. The what? The absolute values. What's the only way to take down absolute values? Splitting. Let's do it. Absolute values split. 1 plus, 1 minus. They're talking about the stuff inside. What's the stuff? Stuff will take over. What do I put here?
X plus 7.
Good. Just plain old x plus 7. This is the positive side. Does that flip the sign? No. So it's going to be greater than or equal to what? 3. Positive 3. Give me the other side while we're at it.
X plus 7.
Uh-huh. Does this flip?
Yeah.
Yes. To
Less than.
less than or equal to? Less than or equal to what? Negative 3. You see what's going on? The negative side, flip the sign. Now go ahead and solve this. Jeff, go.
Oh, so you subtract 7 on both sides?
Good. Does subtracting flip the sign?
No.
No. Adding and subtracting are too weak to flip the sign. So what do you get? X
Yeah,
is.
x is greater than or equal to -4.
Good. Circle that. And do this one too.
So again, subtract 7,
Does that flip the sign?
no,
No. So X is,
less than or equal to -10.
can you graph that on a number line? What 2 numbers are the only ones you really, really need?
Negative 4, negative 10.
-4 and -10. Which one goes on the left-hand side?
Negative 4.
Actually,
What?
which one goes on the left-hand side?
Oh,
of the
sorry,
number?
negative.
Yeah. That I mentioned that because the very first time I did this, I don't memorize every single mistake I ever made in math ever, but there's a lot of them. Okay, just because I was like, darn it, I did exactly what I did. I did -4, -10,
It's either you made very few mistakes or you have a really good memory.
or no, I just made a lot of really spectacular mistakes that were very vivid. So -4, -10 was pretty darn dumb, and I think I got a very interesting comment from the teacher on that one too. It's sort of like not the last time I checked or something like that. But question: solid or dotted? Or solid or open dot?
Solid.
Solid, because they're equals. Which way do I shade for the -10? I want all the numbers that are less than or equal to -10, so which way should I go? To the left or to the right? Okay, to the left. How far does it go? Forever, put an arrow. How about for -4? To the left or to the right? To the right. You basically follow the sign. You go forever, and there is your answer. Does that make sense? Here are your two solutions, and here's the graph. Done.
Will your zero always be on the right side?
Not necessarily. They might have like +4, +10, and it'll be over here, and then 0 over here. It's kind of random. Questions? That is all I have for you. So you are welcome to start pounding away at that. I will write this on the board, or actually I'll write it on this board for the people working at home. The homework number 3A has been modified. I apologize for the typo there. Well, the paste, I suppose, because I copied and pasted wrongly. This is page 98-ish. I'd like to do 1 through 7 odd,
How do you do it?
and then 11 through 21 odd.
So it's just 1 through 21, odd minus 9.
Correct. 1 through 21 odd, skipping number 9. Right. Everybody good? Okay, people listening at home, God bless you all, your health, et cetera, et cetera. Talk to you later.